Thanks for joining us for this webinar. My name is Gavin O'Hare, and my role within CED is in business development and new case management. I'm going to introduce Greg Paulsen shortly, and we are going to speak about air conditioning, COVID-19, and all of our concerns with airflow. So I would ask that if you have a question or a comment that you use the Q&A icon in Zoom, and then I will answer those with Greg as we go through the session, or certainly at the end as time permits. So just wanted to start off with a brief background on CED. We were started by a group of engineering experts from the Naval Academy back in 1987. No surprise, many of our staff have a military background. The picture on the upper right there is the midshipmen a few weeks ago having their socially distant graduation. Crazy times, but we're still pressing on. Now, 30 plus years later, CED has offices where you see the red dots, so we've kind of expanded up and down the East Coast and into the Midwest. This slide calls out the typical areas of expertise that our engineering experts get involved in. And I'm not going to read them to you, but they're there. Today we're going to talk specifically about heating, ventilation, and air conditioning, HVAC, which is an area of expertise that Greg Paulsen has. I'd like to spend a little time on this slide. It talks about the uncertainty of all the issues surrounding COVID-19 and how these respiratory droplets in our sneezes or our coughs, they get into the airflow, and how HVAC systems can transport those respiratory droplets, and how these droplets also can deposit themselves on the HVAC surfaces as well as the ducting surfaces. So these are things we can talk about with mechanical engineering certainty, because we understand airflow and what is the process of the HVAC. But what I find interesting is that the government entities, they tell us to wear masks and they tell us to spread 6 feet apart, but they don't give a clear understanding of why we need to do that. And so hopefully you'll get some of that why after listening to our webinar today. Last week we started out our webinar series talking about moving the restaurant from indoors to outdoors and the premises liability concerns that can create. These businesses are making an effort to move away from the recycled indoor airflow of air conditioning and heating. And so that is why today's webinar is a good segue into talking about that recycled air. And as many of us have seen in the news, back earlier in the year in Guangzhou, China, the scenario of a restaurant setting was addressed, and an abstract was written by the CDC. And essentially, what we're talking about here is the airflow that comes in through air conditioning or heating. I'm running my little red cursor there. You can see airflow comes in, and here's the tables in the restaurant. So the airflow pushes the air across C and then A, and then ultimately table B. So if coughing or sneezing is happening upwind, obviously that can get blown down across the tables, and more people can get the virus on them. And so you don't have to be a sailor to understand what being downwind means. But this lower picture talks about, if you were to cough or sneeze and the airflow is behind you, then it's going to go straight down. If it's at 90 degrees, like it is on the picture on the right here, again, the airflow will bring those respiratory droplets in the direction of wind or the airflow. So next I'd like to introduce Greg Paulsen. And Greg is one of our senior mechanical engineers. He has a military background like many of us at CED, but he also has a great deal of industry and work experience. As you can see on the slide, you couple that together with his education, and I like to think of Greg as all things mechanical. Greg has a hands-on approach because he literally has built and serviced and maintained all kinds of mechanical systems and machinery. So with that said, I would like to turn the slide flow over to Greg. And we're working on it. The technical difficulties are there, but we're transitioning to Greg's PowerPoint slides.
Yeah, sorry about that. I forgot to share the screen first.
Okay. There it is. Thank you.
Okay, thank you for everybody coming and attending this. I'm just going to review a little bit about the COVID first. We've all heard about it. We've seen it in the news, read about it in newspapers. We know that the COVID-19 is a virus. And here's a picture of what the virus actually looks like. It's been reported that it will be transferred through respiratory droplets in the air, i.e. what you sneeze or cough. And it can settle on surfaces, and it can be transmitted by touching those surfaces. Characteristics of this virus are 80 to 160 nanometers, or about 0.07 to 0.15 microns. So remember this size for later in the talk. And just for everybody's reference, this is about 3 millionths of an inch. It's very small.
Is there a filter out there that can filter something that small?
No, not right now, but we're going to talk about that in a while. The typical life in air is reported to be 3 hours and can last 1 to 3 days on surfaces if it settles there. Here's a typical residential airflow. During this COVID-19 pandemic, a lot of us are working at home, so I included this so you can understand how air will flow in your house. And then later on, we'll talk about what we can do to make the airflow better. You can see that outside air can come into your house to your AHU or air handling unit. That's the blower in your house that pushes the air around it. It goes through some dampers, goes into the air handling unit, and then is pumped around your house by these blue lines, supplied to each space in your house. So obviously you're not pressurizing the house with just pumping air into it. Some of the air leaves. If you have a very tight house, most of it is going to go out exhausts that are there on purpose, like these bath exhausts. It can go out a kitchen range hood. If you have a fireplace, it can go out that way. But some of the air that comes in from the outside will go out through these exhausts here. But those are very small. Most of it is recirculated around in your house. So you're supplied, it's supplied by the blue, and then it returns right here back to the air handling unit or the blower. So basically the air is just being recirculated around in your house like this, most of it. If somebody is infected in your house, or if somebody visits that's infected by those virus lives that we looked at a little bit ago, that can stay in your house for a while.
So Greg, the virus is essentially hitchhiking on these respiratory droplets or other things that are in the airflow. Is that right?
Yes, that's right. The virus isn't going to be free floating most of the time. CDC puts out that it is mostly transported by some kind of media, and the media that they are most concerned with is whatever comes out of your body in a cough or a sneeze, sometimes even talking. Here's another residential airflow, typically that you may see. This one has the same air handling unit or blower that takes outside air in, pumps it to your spaces, and then returns it. This one includes dehumidifier, which we'll talk about a little bit later also, and then back to the system. This is, in many houses, you'll see ducting coming back from the spaces and then going back into the air handling unit, such as showed here. It can be like that, or it can just return to wherever their air handler is, into the room. But again, you see recirculation with a little bit of exhaust. In a typical commercial building, it's set up pretty much the same way. You can have outside air come in, go through either your cooling or heating, depending on what season it is. A supply fan or a blower will pump it into the spaces. It will either heat or cool those rooms and then be returned. You'll see that you have a damper here and a damper here and a damper here. These are controlled by the system from your building controls, and that allows however much quantity of outside air you want to come in or exhaust the air. We'll talk a little bit more in a future slide about how we can get, why we would want more outside air and exhaust to come in, and explain the upsides and downsides of that. But this is, again, typical office building like you would be working in. So these are the two kinds of places that most people will be working in, either your office or your home. You see that there's recirculation there. What can we do knowing that COVID is transmitted by droplets or on surfaces in terms of your HVAC system to reduce anything that might be in your space? Before we discuss that, we want to understand a little bit about the air that's going into your space. When you're designing a system, be it a building or a house, you have what are called air change requirements. An air change requirement is how much air is filling up a volume, be it a room or a garage or just one of the spaces in your house or in your office. How many times the air will completely change out in an hour. It's based on the number of personnel per volume of space. For example, in private offices like a law firm, the base air change requirement is 3 air changes per hour, okay? Now that just means 3 air changes. It can be recirculated air, or it can be fresh air, it can be mixed air. You just have to design the system so that the volume of air that is in a certain space will be completely changed out every hour. In public offices like the DMV, where you have many, many people going in and out, and the number of people aren't ever known for any time of day, the air change requirement is a little bit higher. It's 4. So this is changing the air every hour. Additionally, there's makeup air requirements. Now, makeup air, it will be included in the air change, but makeup air is fresh air. There's design requirements based on the number of personnel that are expected to be working in certain spaces. You're not allowed to recirc air over and over and over again, even if you're meeting the air change requirements. You have to have some fresh air put into the air that you're pumping around in your office spaces or in your house. States are the ones that will put out the requirements for what the makeup air are. They're different across all states because all states have different environments that they're taking air from. Sometimes even municipalities have requirements that are even more stringent than the states. So air change and makeup air requirements aren't to be confused. Air change is changing out the volume of air. Makeup air is the amount of fresh air you're adding to the air change. So what can we do? What can we think about to reduce a COVID risk in residential buildings, like in your house? Remember, we talked about we're recirculating air here. We have some outside air coming in when the unit controls decide that it needs outside air. And we may have filters in the system. We may have different kinds of exhausts. One option that has been discussed is filtration. Remember before we said that the size of the virus is 0.07 to 0.15 microns, okay? Well, right now, the filters on the market, the MERV 13 design is the most stringent. It is the filter that will filter the smallest particulate out of the air, and it's at 0.3 microns. So it's black and white. A filter cannot take a virus out of the air. However, we talked also that the viruses are attached to a media, usually moisture. A filter can get that out depending on the size of the moisture. There's a downside to that though. The filters aren't there to filter out moisture. The filters are there to filter out particulates like dirt, dust in your office or in your house. That's why they have a 30-day change out typically, because if it gets clogged up with dirt, your system doesn't run anymore. Another downside, go ahead, Gavin.
I was just going to say, so if we know the virus can stay in the air from 1 to 3 hours, and you're in an enclosed place where the air is being recirculated, that filter, and let's say there's a lot of coughing and sneezing going on, then that filter can get saturated. Is that correct?
That is right. That's the other downside that I was going to mention. Okay. The other downside is that as the filter is filtering out the dirt or any moisture that's laden with virus, you could actually be having the viruses build up on the filters. So when you go to change it out, it might be an active germ filter, and you could be infecting yourself just by doing the maintenance on your own system. So filtration is not, filtration can help, but there are downsides. Another thing we can do is dehumidification. We mentioned that the virus is on the media of moisture in the air. If we dehumidify, make it drier, that could cut down on virus-laden moisture that's in the air. The best things that you can do right now, and it's not a fix or it's not a solution, but the best thing you can do for your residents is maximize the amount of outside air that you bring into your house. Okay, what that's going to entail is opening the dampers and taking in outside air. That will almost ensure that you're 100% fresh air in your house. There'll be a little bit of recirculation, but most of it will be fresh air. Also, opening windows, opening doors. You can see the picture right here. They have their their patio door open here. Get as much fresh air into your house so you're recirculating fresh air or supplying fresh air and not recirculating potentially virus-laden air. Maximize the recirculation for maximum outside air changes. Keep the blower on. All thermostats have a fan only. They also have a run fan all the time setting. If you're recirculating and maximizing air, you're helping get fresh air throughout your house. And that's about all for that. So these are the two big ones right here that are easiest to do and have the best chance of reducing your risk. Maximize outside air, maximize recirculation of fresh air. In a commercial building, it's pretty much the same. Filtration, same as before. There's not a filter out there that can filter out the virus. And again, if you have a lot more filters in a commercial building, if you have a lot more filters, so you'll be changing them out less than 30 days. And you could have an infected filter. And so you'll be putting your maintenance staff in danger. Dehumidification is an option. Most office buildings have dehumidification systems. You should run that. There's been talk about UV light treatment systems for countering any COVID risk. Right now, there's no UV light treatment systems that could be put into any kind of HVAC system, be it residential or commercial. You just need too much light, and there's too much air going through there. There's not enough treatment time. So UV light treatment systems for HVAC systems, both in commercial or residential, that's not really an option. Again, just like residential, increase your outside air, maximize the dilution of any recirc air, and also run the blower all the time so you're recirculating all that makeup air. So, whoops, sorry about that. What could be a downside of maximizing outside air or running your blower all the time? You're going to see an increase in your power bill because, for instance, in the summertime, if you take in outside air all the time, it's going to be humid. And so you're going to be running your dehumidification more. You're going to be running you're going to be cooling outside air, which is going to be much hotter than what is being recirculated. Almost the same thing in the wintertime. If you're bringing in outside air, you have to heat that air, whatever temperature it is, and rather than heating air that's been recirculated and is close to what the setting is supposed to be anyway. So this is our summary of how to reduce your risk, maximize your outside air, maximize recirculation for maximum air changes, and minimize personnel per space. And that's all. If Gavin has any questions for me or for himself, we'll answer them now.
Greg, you want to shift to that last slide, the Q&A?
Yes.
I wanted to thank you for that very informative presentation on how HVAC works in the residence and the workplace as we return to work. At CED, the typical work that you do for claims and litigation involving HVAC are anywhere from fires to mechanical failures of the system, water leaks. Oftentimes, there's questions of whether the HVAC is designed properly. You talked about the air change requirements, and there's some math and science on how you design an HVAC. So I'm not sure we'll be getting involved in the COVID side of this, but certainly you understand how the system works. So.
That's right. We also do building studies for when an air conditioning system is not working correctly. Usually it's due to leaky windows or bad building envelope.
Okay. Greg, we have a question here, and I'm not sure if you have the answer to it, but it's how long must the virus be exposed to UV in order to kill the virus?
I don't have that answer.
Yeah. Okay.
No.
Couple of other takeaways from our presentation. I plan to now be more cautious when I go into restaurants and buildings and not hang out at the exhaust of a air conditioning unit. I've also, based on what you talked about on the makeup air and trying to increase that by opening windows and various machinery to allow more air into the building, that's going to require more work on the HVAC system. And as you mentioned, that's going to equate to greater electricity and power bills. So as we move forward into the hot months, these are things that we're going to have to keep in mind as well. So with that said, Greg, there's another question here. It's any special concerns for churches or any rooms with very high ceilings?
Oh, that's a great question. So the way that I explained reducing the risk for residences and office buildings, that's also going to go for the church. Now, as far as the high ceiling goes, since we're dealing with a moisture, a virus in moisture, it's not a floating media. It's a media that goes out from the infected person and settles on a surface or settles on the ground. The high ceilings are not going to kind of play into this equation that much. But you're still going to want to maximize your outside air and maximize the recirculation. If I don't know if that answers your question, or if you were looking for more of a design question on like how to recirc better, you can follow up with a question if I didn't answer that correctly.
And our contact information obviously is on the slide too if we don't get to your question. So thank you, Greg. Another one is if you haven't had any person in your house since March, and I'm assuming that let's say you haven't left the house, and so you're not bringing in contaminated people, if you will, or virus exposed people. How important is it to maximize that outside airflow or other measures? And I think some of these you have to apply common sense to is, where could that virus be coming from? Could it come from the groceries that someone brought to you? Have they been wiped down? But if you're minimizing the people who might have had COVID coming into your home, then yeah, you've done a good job, and you don't necessarily have to be as aggressive as Greg has suggested with these airflow induction measures. Is that accurate, what I've said there, Greg?
Yeah, that's pretty accurate. I think it's still, you can't control everything. Not letting people in your house and yourself, you've stayed in the house and not been exposed to anybody. That's certainly the two biggest things that are going to bring in viruses. But like you mentioned, you're also bringing in other stuff that you can't control. So it's still a good idea to consider these COVID reducing risk recommendations.
Okay, a couple other questions here. For people who work in the high-rise buildings you talked about,
yes,
where they cannot open their windows, is there anything that they can do as just an employee, a tenant in the building, if you will?
Yes, well, I don't know what those people can do, but the people that take care of the building, they would change their building controls to maximize outside air, maximize exhaust, and keep the blower running all the time. What that does is that maximizes the air changes per hour, and that also maximizes the amount of, or minimizes the amount of recirculated air.
And then here's another question. Can strategically placed fans be helpful? For instance, if you're in your standalone room in an office building and you put a fan aimed at you or away from you, could that help with airflow, keeping the recycled air away from you?
No. So what I'm imagining when you ask that question is that you're in your office and your door is shut, and your office is being supplied by the building system or your floor system. That air comes into your office and then it leaves the office through a return. Basically, what your fan is doing is just helping recirculate that air in your space, but the potentially infected air is still coming in there. It wouldn't make a difference.
And one last question, because we want to be mindful of everybody's time. If you're reopening your business after 3 months closed, do you need to undertake a deep clean?
Well, as far as HVAC goes, I would say you would want to change your filters out. You would want to run the blower for a period of time, like I would recommend like 24 hours before anybody comes back. Get the system set up in the manner that we discussed. For deep cleaning, not in my expertise. I don't know that one.
Okay, well, very good. I think we've gotten to most of the questions. Again, our contact information is there if we haven't answered your question. And we thank you all for joining us for this webinar. And Greg, thanks for your effort to put it together. Have a great day and be safe and be productive. Bye now.
All right, goodbye, everyone.